Good morning, students. In the last class we discussed arithmetic operations on pointers. So what are the arithmetic operations we can perform on pointers? Increment operation, decrement operation, addition operation, subtraction operation. Then what are the things or what are the operations we cannot perform on pointers? We cannot multiply two pointers, we cannot divide pointers. Okay, so we cannot subtract the addresses of two pointers. So these are the operations we cannot perform on pointers. Let us understand these concepts through an example. Operations performed on pointers. First one. Addition operation. Addition operation. Second, subtraction operation. Then increment operation. Decrement operation. Okay, see, addition operation means we can add an integer to the pointer. Like that we have to understood this. For example, if I declare an integer pointer int star p semicolon, there is a memory allocation for this pointer. Name of this pointer is p. Let us consider the address is 500. If I write like this, if I perform addition operation on this pointer, p is equal to p plus 1. Okay. So what is there in the p? Nothing is there in the p. So I have to take some variable and I will assign the address of that variable into p. If I consider n is a normal variable. If I write instruction like this, p is equal to ampersand n. Okay. So what is the address of n? Let us consider when we declare n, for that also memory will be allocated. I'll consider 300. So p is equal to ampersand n. So see, 300 will be stored in p. Understood? Now, if I increment p is equal to p plus 1. If I perform addition operation on this pointer p, what happens? Right now p is pointing this memory location 300 and 301, isn't it? 300 and 301. The whole thing we consider a 2 byte. See here, n, it is an integer type variable, so it occupies 2 bytes of memory location. The starting memory address is 300 and 301. Next, p is equal to ampersand n. So the address of n, that is we consider first memory address 300 will be stored in p, this pointer. Right now p is pointing the memory 300. I added one number, that is 1. Okay, what does it mean? P is a integer type pointer, no? So one time increment, addition means incrementation only. One time increment, right now it's pointing 300. Now it is an integer type pointer, so it points 302. Some memory locations are there, no? Here, further memory locations are there. 300. Right now it's pointing 300. If I add one to this pointer, one time increment, this pointer is an integer type, so it points 302. Now the P contains 302. In this way you have to understood addition operation on pointers. Understood? Now subtraction operation. P is equal to P minus 2. Right now what is there in the P? 302 is there. P is which kind of pointer? It is an integer pointer. If I subtract this pointer with the value 2, 2 times decrement. So one time decrement, that is 2 byte. 302, it move backward, that is 300. Again 300, from 300 again 2 byte, it decrement by 2 bytes, that is 298. 298 will be stored in the P. Some address, some memory, its address is 298 and that memory location is pointed by the pointer. So what you have to understood from these operations, when we add any integer to the pointer, we can add only integers. Okay, when you add an integer to that pointer, not only the value will be changed, it's pointing to that memory location. So in this example, initially I assigned a value, I assigned the address of n. What was the address of n? 300. 300 will be stored in P. Understood? So I add 1 to this pointer. P is equal to P plus 1. So what does it mean? That pointer will be incremented by 1 time. Understood? So one value will be added. One time you have to understand like this. One time, not if it is 300, you don't write 301. It is one time incrementation means first it sees the type of pointer. What type of pointer I have taken here? Integer pointer. One integer occupies. So it pointing an integer memory. That integer memory requires a 2 bytes. So when I increment, it moves 2 bytes next memory location. Okay, the whole 2 byte is reserved for one integer. That's why it goes to next integer memory, next consecutive integer memory, 2 byte memory. Now, so what we learned? Addition operation and subtraction operation. Now increment operation. Increment P plus plus. Right now P contains 298. I will consider RAM here, memory cells in the RAM. These are the memory cells. Each memory cell occupies 1 byte. It requires a 1 byte. 1 byte. The size is 1 byte. Let us consider the addresses are like this: 200, 201, 202, 204, 205, 206, 7, here 208, 209, 210, 211, 212, 213, 214, 215, 216, 217, 218, 219, 220, 221, 222, 223, like that the memory addresses will be goes on. See here. Let us consider the address of P is 212. Okay, 212 is the address of P. And address of N I'll consider somewhere. I'll consider here 216 and or okay 216 and 217. So N, I'll extract this memory here. So what is the address of N? 216 is the address of N. Now ampersand N, address of N, 216 will be stored in P. Understood? Now P is equal to P plus 1. What happens? P, what is there in the P? 216 is there. P plus 1 means increment, one time increment. So what is the type of pointer? Integer pointer. So one time increment means 2 bytes. Right now P contains 216. P pointing this memory location. So this P, name of this memory is P, and this is N, 212, this memory, okay, 212, P. So P plus 1, one time increment. So this memory is pointing 216, now 218. Next, right now it points 218. Here I must write 218. Understood? So this 218, it doesn't have any identifier here. Initially I took a variable n, so randomly it allocates a memory 216. Now I incremented p value by 1, so it moves next memory location. ಆ ಮೆಮೊರಿಯಿಂದ ಎಲ್ಲಿ ಸ್ಟಾರ್ಟ್ ಆಗಿತ್ತು, ಯಾವ ಮೆಮೊರಿ ಅಡ್ರೆಸ್ನ ಸ್ಟೋರ್ ಮಾಡಿದ್ವಿ ಅದರಲ್ಲಿ, ಅಲ್ಲಿಂದ 2 ಬೈಟ್, ಅಂದರೆ 216 ಇತ್ತು, 16 ಇಂದ 218. ಸೊ 218ಗೆ ಪಾಯಿಂಟ್ ಮಾಡ್ತಾ ಇದೆ ಪಾಯಿಂಟರ್. So in this way you have to understood addition operation on pointers. You should not write like this, just I have mentioned addition operation. We can add an integer to the pointer. Operations performed on pointer. We have to write the explanation here. We can add an integer to the pointer. We can subtract an integer from a pointer. Then increment operation. We can increment a pointer, we can decrement pointer. Like that you have to write. We can add pointers, we can subtract pointers. You should not write like that. We can add an integer to the pointer. If you add 2 pointers, what happens? That result will be another memory location. If that memory location, by that address, if the memory is not there, it's wrong. So it gives that memory is not there, isn't it? So while writing the explanation how to write, we can add an integer to the pointer. We can subtract an integer from the pointer. We can increment pointer, we can decrement pointer. So from these 2 examples we can understand what is meant by adding an integer to the pointer. Let us consider this line, P is equal to P minus 2. What is there in the P? Right now P contains 218. P minus 2 times decrement. 1 time decrement 2 byte, 216. Now again it move back. 218 no 216, it comes to 216. Again one more decrement, 214. Now pointer P contains 214. Understood? Next, increment operation. P plus plus. You all know what is increment operation. Plus plus means it's 1 time increment. If you want to increment 2 times, you should not write again plus plus. It's wrong. There is no such operator in C++. If you want to increment 1 more time, by using increment operator, again you must write P++. So plus plus means 1 addition of a value 1. Now P plus plus. Right now what is there in the P? Which memory location that P is pointing? 214. This memory location is pointed by P. Now P plus plus means 1 time increment. So 1 time increment means based on the type of pointer. Pointer is a integer type. So 2 byte memory will be incremented. 216. So now this pointer contains 216. Next, if I write P minus here, P has to, the value of P has to decremented by 1. What does it mean? What is there in the P memory address? So 1 time decrement. What type of memory that pointer is pointing? Integer type memory. So 1 time decrement means 2 bytes. So 214. Again it's pointing 214. So in this way you can understand these operations. So these are the operations we can perform on pointers. Along these operations, some more operations are there. What is the next operation? We can add two pointers when those pointers are pointing the same array elements. Understood? See here. If I consider an array, integer array 5, A, 0, 1, 2, 3, 4, 5, sorry, size is 5, no? $200, 202, 204, 206, 208. Okay. So if I take a pointer like this, here also memory locations are there, but we did not reserve these memory locations. 209, sorry, 210, 212, 214, 216, 218, 220. If I consider a pointer P1 and P2, now I'll initialize the address of first memory location to this pointer, ampersand A of 0. So now P1 contains the address of first memory location, P1, and I'll consider address 700. Here P2, I have taken two pointers and these two pointers are pointing the same array. 600 I'll take here. Right now I initialized P1 is equal to ampersand A of 0, that is first memory address. What is there in the P1? 200. And I initialize P2 is equal to, here I'll write, P2 is equal to ampersand A of, I'll take A of 2. What is there in the A of 2? 204. Now we can subtract two pointers. So difference we can find. P2 minus P1. What is there in the P2? 204. And what is there in the P1? 200. So what is the difference? 4 bytes. So we can, how many bytes they are, how many bytes difference is there, we can find. Understood? So when we can add two pointers, when those two pointers are pointing same array elements, then we can add these two pointers or we can subtract these 2 points. If you can add these 2 pointers, we can get another memory location, that is a valid memory location. P1 plus P2, what is there in the 200? 200 plus 204. So bytes, how many bytes? You have to consider the bytes here. 204 and 200. So 404. There is another memory location that whose address is 404. In that way we can calculate. So further, if you write like, if you goes on like this, we will find that memory address. So conclusion is, we can add 2 pointers and we can subtract 2 pointers when those 2 pointers are pointing the same array elements, then only we can perform these type of operations. Understood? So from this, what we understood, what are the operations we can perform on pointers. And one more point I will explain here. See, if I take different type of pointer, so it is an integer array. If I take floating type pointer here, float P2, I'll take P. So why I am taking this kind of pointer? Why should we take compatible pointer? I'll explain. If I take float type pointer, you all know the nature of pointer. Pointer, it stores the address of memory location. Okay. So whatever the type of pointer, it occupies 2 bytes of memory location. in order to store the address of this pointer, this location, if I write like this, P is equal to ampersand A of 0. What is there in the P? I'll consider P, 400 is the address, so 200 will be stored in P. Now, if I increment P plus plus, P is a pointer to the array. Okay, if I increment this pointer, what type of pointer it is? Floating type pointer. Through this pointer, I am going to display the content. If I store values like this, 5, 10, 15, 20, 25. Assume there is an array, it contains a value, it is an integer array. So each memory location is 2 byte. And I have taken a pointer to this array that is different type, floating type. Why? What is the thing I am going to explain is, why should we take compatible pointer? If it is integer array, I should take integer pointer. But I have taken floating type pointer. Why we should not take different type of pointer? I'll explain here. See, I have taken floating type pointer. If I increment that pointer, I want to display the content of these memory locations. Right now, I'll display like this, cout. After this, I'll display like this, cout, insertion, okay, star P of star P, okay. What is there in the P? 200 is there. Star P means the content of this memory location. So it display 5. Now I increment P in order to display second element. P plus plus I'll write here. How many bytes it increments? 4 byte, because P is a floating type pointer. If it would be integer type pointer, then it would be incremented by 2 byte, so that I can display 10. The next memory location value will be displayed. But the thing is different here. I have taken floating type pointer. So if you increment that floating pointer one time, it moves 4 bytes. 4 bytes next memory location. So 200 is there, no? So it goes to 204. What is there? 204, 15. So it skips this value. For this reason, we have to take same type of pointer. Okay? That's why we should not take float. I must take int. I hope you clear with this explanation why we should take same type of pointer to point the memory location. So one more point, we can add 2 pointers when they points same array, like that. We can subtract, sorry I did not write here, we can subtract 2 pointers when they point same array. Clear? I hope you understood this explanation. Next, operations which cannot be performed on pointers. Operations cannot be performed on pointers. Okay. So what type of operations we cannot perform on the pointers? We cannot subtract. We cannot subtract 2 pointers. We cannot add 2 pointers. We cannot multiply 2 pointers. We cannot divide 2 pointers. So these are the operations we cannot perform on pointers. I explained here. So why we cannot subtract 2 pointers? They allocate different memory location, random allocation. If you subtract 2 pointers, you may get some value. So it is not a invalid, it may or may not be not a valid memory address name. Sorry, memory address. And we cannot add 2 pointers. Here also, if you add 2 pointers or if you subtract 2 pointers, it may or may not be a valid memory address. And we cannot multiply. Here, addition means when we add an integer to the pointer, what does it mean? It is a multiplication. If you add 1, if I take int star p is an integer pointer. If I add 1 to this pointer, p plus 1, one time increment means 2 bytes. Isn't it? Because it is an integer pointer. If you add one more value, 2 times, 1 time, 2 times, 3 times, like that. So addition is nothing but a multiplication. So again we cannot, it is not possible to multiply 2 pointers. It is an invalid operation. Like that we cannot divide also. Subtraction is nothing but division. Isn't it? 1 time decrement, 2 time decrement, 3 time decrement, that is a division. 2 will be reduced there if it is an integer pointer. If it is a floating type pointer, 4 will be reduced. So in the pointers, addition operation is nothing but a multiplication and subtraction operation is nothing but division. So there is no actual multiplication operation and division operation on pointers. So like that. Now we cannot subtract 2 pointers, we cannot add 2 pointers. So how to understand this? So there are different pointers are there, p1, p2, p3. Though they have they are same type of pointers, we cannot add, we cannot subtract unless they pointing same array elements. So this, when they point the same array elements, then we can add and we can subtract. Apart from that, we cannot add, we cannot subtract, and we cannot multiply, we cannot divide. Understood? So addition anta bandaga pointers alli addition operation illi nimige don't get confused with this. We cannot subtract 2 pointers, we cannot add. Neevu almost students ella heng baritare exam alli, we cannot add, we cannot subtract, we cannot atara baribardu. Sentence complete ಮಾಡಬೇಕು, then only you will get a marks. Operations cannot be performed on pointers anta ಹೇಳಿದ್ರೆ, we cannot subtract 2 pointers or 2 pointers cannot be subtracted. ಅಲ್ಲಿ ಆ ಥರನೇ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು, 2 ಪಾಯಿಂಟರ್ಸ್ ಅಂತಾನೆ ಬರಬೇಕು. ವಿ ಕೆನಾಟ್ ಆ್ಯಡ್ 2 ಪಾಯಿಂಟರ್ಸ್, ವಿ ಕೆನಾಟ್ ಮಲ್ಟಿಪ್ಲೈ 2 ಪಾಯಿಂಟರ್ಸ್, ವಿ ಕೆನಾಟ್ ಡಿವೈಡ್ 2 ಪಾಯಿಂಟರ್ಸ್. ಲೈಕ್ ದಟ್ ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್. Then operations performed on pointer anta bandaga, we can add an integer to the pointer. Like that you have to write. We can add pointers, we can subtract pointers. It is wrong. You should not write like that. Addition operation means we can add an integer to the pointer. ನೀವು ಇಲ್ಲಿ ಈ ಥರ ಬರೆದ್ಬಿಡಿ, we can add an integer to the pointer. We can add an integer to the pointer. Next, we can subtract an integer from a pointer. We can subtract an integer from a pointer. Now next we can increment pointer, we can decrement pointer, and these points are same. What are the operations performed on pointer and what are the operations we cannot perform on pointers. Next concept, static allocation and dynamic allocation of pointers. Float. Let us consider an example. Float A, comma B. So this is normal declaration. We have discussed these declaration in all previous examples, previous programs. If you want to store a floating number, so we will take float is a data type and variables. How many values we want to store, that many variables we have to declare. So this is a normal procedure. What happens when we write this kind of declaration? If you want to store two floating numbers, we will write like this: float A, comma B. If you want to store two integers, int x, comma y. Int x, comma y is there, no? Then two integer variables. Here A, I'll consider the address is 500, and B, I'll consider address is 700. Next, int x and y. For x 300 and for y I'll consider 900. So these two are floating type. So they are 4 byte of memory location, and this is 4 byte, 2 byte, and this is also 2 byte. When we write this statement, there is a memory allocation in the RAM. That memory allocation takes place during compilation time. When we write a source code, that source code is high level language. Okay, we have written that instructions in English language, isn't it? So these high level languages cannot be understandable by machines, that is processor. So processor can understand only machine language, that is binary language. So one has to convert this high level language into machine language. So we need a translator. So which translator we used here? Compiler we used. Compilers also there, interpreters also there to convert high level language into machine level language. We used compiler, Turbo C++ compiler we used, isn't it? So that compiler has to convert high level language into machine level language, that is object code. During that process, memory will be allocated. Okay. When you execute a program, when it is ready to run, ready to execute, only thing is we have to input values to that allocated memory locations. These memory locations are allocated at the time of compilation. At the time of execution, I cannot modify the size of memory location. It is fixed. ಯಾವಾಗ ಅಲೋಕೇಟ್ ಆಗಿರುತ್ತೆ, ಕಂಪೈಲ್ ಟೈಮಲ್ಲೇ ಅಲೋಕೇಟ್ ಆಗಿಬಿಟ್ಟಿರುತ್ತದೆ. ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡುವಾಗ ನಾನು ಏನೂ ಚೇಂಜ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಅಲೋಕೇಟ್ ಆಗಿರೋ ಮೆಮೊರಿಗೆ ಏನು ಮಾಡ್ಬೋದು, ವ್ಯಾಲ್ಯೂಸ್ ಇನ್ಪುಟ್ ಮಾಡ್ಬೋದು. ಆಫ್ಟರ್ ದಿಸ್ ವಿ ಕ್ಯಾನ್ ರೈಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಲೈಕ್ ದಿಸ್, ನೋ, ಸಿ ಔಟ್, ಎಂಟರ್ 2 integers, isn't it? C in extraction integers, no, x and y. So when this line executes, what happens? User has to input values, and those values have to be stored in these two memory locations. Andre execution agavaga memory allocate agalla. Yavtara, when you write this type of declaration, this is called static declaration. Then what is the definition of static memory allocation? Allocation of memory takes place during compilation time or before execution. Okay, so we cannot modify the size during execution. I want to store only one integer, I don't want another memory location. Is it possible to delete that memory location during execution? No. How much memory has allocated at the compilation time? For those allocated memory, you must enter a value. That is the rule here. So one thing, allocation takes place before execution. We cannot modify the size of memory during execution. We cannot delete the memory location. Okay, and if you don't want to input value for this memory location, and it will be wasted during execution. So these are the disadvantages of static allocation. Let us understand the disadvantages of, further we will understand the disadvantages of static allocation by considering arrays and all. Okay, right now what you need to understand, static allocation means allocation of memory takes place before execution of the program. Then when that static allocation, what type of instructions will allocate static memory? These kind of instructions. So what is the general syntax? Data type and variable list. ಯಾವ ತರದ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ನ ಬರೆದ್ರೆ ಸ್ಟ್ಯಾಟಿಕ್ ಅಲೋಕೇಶನ್ ಆಗುತ್ತೆ? ಈ ತರ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್, ಡೇಟಾ ಟೈಪ್, ವೇರಿಯಬಲ್ ಲಿಸ್ಟ್. ಈ ಒಂದು ಫಾರ್ಮ್ಯಾಟ್ ಅಲ್ಲಿ ನಾವು ಮೆಮೊರಿನ ಅಲೋಕೇಟ್ ಮಾಡಿದ್ರೆ, ಈ ತರ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಬರೆದ್ರೆ ಇದನ್ನ ಸ್ಟ್ಯಾಟಿಕ್ ಅಲೋಕೇಶನ್ ಅಂತ ಕರಿತೀವಿ. ಅಂಡರ್ಸ್ಟುಡ್? ಇಫ್ ಯು ವಾಂಟ್ ಟು allocate memory for an array, I'll take int a of 5 here, semicolon. Okay, so a of 5, how many bytes? Total 10 bytes. Each element requires 2 bytes. So the name of array is a. So here also I have declared a of 5. A of 5 means user has to input 5 elements there, and if you want to input one more element, you cannot input, because this kind of allocation, this type of instruction leads static allocation. During execution you cannot modify the size. ಈ ತರ ನೀವು ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ನ ಬರೆದ್ರೆ ಏನರ್ಥ? 5 1 2 3 4 5 no sorry, memory locations are there here in the RAM. There are memory locations are there, but I allocated up to here. So 5 memories. I want to store only 3 elements. I have taken 5, but I want to store 3 integers. So up to here we can use 0 1 2. So these 2 memory locations will be wasted. Or if you want to store one more element, 6th element, for this memory location it is not allocated. So these are the disadvantages of static allocation. So in order to overcome these disadvantages in real time with this static allocation, we cannot give solution. So we need dynamic allocation. Whenever during execution, whenever we want memory, whenever we want to input, or whenever we want to store a value, that program has to automatically allocate the memory. So to make a program more dynamic, we have to take dynamic memory allocations here. We need dynamic memory locations. Then how to store, how to allocate a memory dynamically? Let us see. Dynamic memory allocation. See here, in dynamic memory allocation what happens, how to write? I'll start with the small programs or small examples. How to allocate a memory to an integer? If you want to store an integer, usual method. What is the usual method? Int a, isn't it? So what happens when you write this instruction in RAM? Somewhere 2 byte memory will be allocated. Its name is A. I'll extract this memory and show you here. 2 bytes. This is 2 byte memory I have taken here. Its address, let us consider 300, 302, 303. So 302. So this memory, when you write this instruction, the memory allocation will be like this, and this particular memory have particular identifier. So what is the name of this memory? A. By using that particular identifier, we can access the content of A. So I hope you all familiar with this concept. So this is a static allocation. Okay. Now during execution, the thing is you have to input a value to this memory location. If you write cin statement like this, cin extraction A, I'll write like this. Then at the time of execution, value will be entered by the user and that value will be stored in this memory location. Understood? Now how to write dynamic memory? What is the syntax? If I allocate a memory for an integer dynamically, what is the instruction? I repeat this, you have to observe carefully. See, this is a static allocation. Allocation of memory takes place before execution. The allocations will be ready during execution. Only thing is value to be input to that allocated memory locations. Now dynamic memory, how to use that, how to write instruction for dynamic memory allocation for the same integer. Data type int star p is equal to, this is a pointer, what type of value you want to store? Integer. So I have to take integer pointer here. New is an operator, it is a keyword, you should remember this. New data type, what type of value, what type of memory this pointer has to point? Integer type memory. That's why I must write int here, semicolon. In this way we can allocate memory dynamically. See, when you write this type of instruction, how would be the memory allocation in RAM? See, star p is there, no? Int star p. Somewhere 2-byte memory is allocated for p. Let us consider the address is 600 and 601. 2-byte, no? Each byte is one, each memory cell is 1 byte and it has its unique address. So total 2 bytes are required for p. So we always consider the first memory address 600. 600 and 601 are the addresses of this memory, but when you display the address of p, it displays 600. It consider the first memory address. So this p, how does it allocate the integer memory? I'll show. So int star p, there is a memory for this pointer, and assignment operator, it assigns. New int, new, what is the purpose of new? New is an operator, it creates a new memory location, that is integer type. A new memory location, somewhere a new memory location that is integer type, so it occupies 2 bytes. The address I'll consider 400 and 401. This memory does not have any identifier. Every time, how many times you execute this line, that many new memory locations will be allocated. So this memory location address is stored in p, because I have written assignment operator. So 400 is stored in p. It means p is pointing this memory location. I hope you understood this concept, how dynamic memory will be allocated. How to implement in the program? I have to write this instruction in a function. If I write function, consider void create. I'll take a function like this, void create. So this function includes this statement. During execution, how many times you call this function? We have written program, isn't it? How many times we call this function? It will create some memory at the time of execution. Actually, through the program, if I explain, you will be understand clearly. Right now, what I am explaining, how to allocate an integer memory dynamically. Right now, what you have to understood, how to allocate a memory for an integer dynamically. ಒಂದು ಇಂಟೀಜರ್ ಮೆಮೊರಿನ ಡೈನಮಿಕ್ ಆಗಿ ಹೇಗೆ ಅಲೋಕೇಟ್ ಮಾಡೋದು. ಇಂಟ್ ಸ್ಟಾರ್ ಪಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ನೇವ್ ಇಂಟ್ ಅಂದರೆ ಒಂದು ಇಂಟೀಜರ್ ಪಾಯಿಂಟರ್ ಒಂದು ಇಂಟೀಜರ್ ಮೆಮೊರಿನ ಪಾಯಿಂಟ್ ಮಾಡ್ತಾ ಇದೆ. ಓಕೆ, ಸೊ ಹೀಗೆ ಇದನ್ನು ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡೋದು ಹೇಗೆ, ಹೌ ಟು ಇಂಪ್ಲಿಮೆಂಟ್ ಇಟ್, ಐ ವಿಲ್ ಶೋ ಯು. See here, I'll take two functions here. Sorry, I'll take class. Name of the class is demo. Okay. In the public section, I'll take two functions, void create void display. Now close. So I will define this function outside the class. Return type is void, class name demo, scope resolution operator, and function name is create. I'll create integer memory dynamically. So that instruction I'll write in this function. Int star p is equal to new int semicolon. So what happens here? An integer memory, that integer memory is pointed by this pointer. That new integer memory is there, no? For that memory there is no identifier. That memory is identified by this pointer. So what is there in this pointer? Address of that newly created memory location. So how to understand this? When you write this statement, what happens? I explained before. I'll write here. P, this is a RAM. Okay. Somewhere the memory will be allocated for P pointer, and let us allocate memory to an integer here. P, that is, it doesn't have any identifier, no? I'll consider the address is 400 and 401. Here I'll take 200 and 201. So star p, int star p, first p there is a memory, and new int, an integer memory, a new integer memory that is 2 byte, it doesn't have any identifier, and its address will be stored in this pointer. So how to access this memory? Through this pointer only we have to access, because it doesn't have a particular identifier. Okay, so this pointer points this memory location. Now I want to input a value to this memory location. This is an integer memory. This memory is pointed by this pointer. Now I want to input a value. How to input? Cout, enter an integer. If it would be static allocation, what happens? We have to take a name of that memory location and we can input a value, isn't it? But in this dynamic allocation, this memory doesn't have a particular identifier and it is identified by this pointer. Enter an integer, cin extraction. See, if I write P, what is there in the P? 400. I want to input a value to this memory location, so I must write star P here, semicolon. function close. Now display function, void demo scope resolution disp cout enter, the given integer is star p, we must write here. Okay. And one more point you have to observe here, star p. So it is a variable, it is created locally in this function, so it cannot be accessed through this function, so I'll display from here. Cout. So we don't want one more function here. Right now I have taken simple example. Given integer is star p. Okay. So now from main function, void main, how to use this dynamic allocation, how to show the dynamic allocation. See, I will take a menu like structure here. Cout. If I press 1, it has to create a memory and it input a value and display. And 2, it has to exit from the program. 1, create, \n, 2, exit. In this way, I have written the program. I consider this situation here. So, in do, I'll write cout, enter your choice, Our choice may be 1 or 2 like that, isn't it? These are all integers, so I have to declare an integer variable here. Int c I'll take, choice. Now I'll take, you can take if else, for this if else is enough, or switch. I'll pass C here, case 1, which function I should call? Create function. So create is a member function. To call that function, we have to create an object. So at the beginning of the main function, I'll create object, void main, demo d, d dot create, open close semicolon. Case space 1 colon d dot create, then break. Case 2 colon d dot, default, I'll take default, I have taken only one case now, default exit. So exit, it requires a header file process.h, # include process.h. and switch close. Now if you want to continue, let us give a chance to user. See out. Do you want to continue? Do you want to continue? Your answer may be yes or no. Yes, I'll take as Y, and no, I'll take as N. So these Y and N are character type answers, character type data. So when the statement display on the screen, do you want to continue? User may input yes or no. So for yes, in order to indicate yes, let us consider Y. To indicate no, let us consider N. So if user press Y, what does it mean? Yes, he wants to continue. If he press N, he doesn't want to continue. So this Y and N are character type data. To store the data, we need character type variable. So I declare here char. I'll take A. Name of the memory is A. Cin, extraction A. Now do close. So I have taken do while here. Do open, do close, while, open parenthesis. If your answer is Y, then only that loop has to execute again. My answer, the user's answer may be uppercase Y or lowercase y. We have to consider both here. While A is equal to capital Y. So I'll write here. Cin, I'll close here, I'll write here. After cin statement, closing brace. This is the close of do. You all know the syntax of do while. While A is equal to answer. What is there in A? Our answer is there in the A, capital Y, or this is OR symbol, logical OR operator. A is equal to small y, semicolon. So the program has to consider both cases, uppercase and lowercase. Now main function close. Let us see the execution. Always execution starts from main function. See here. First, this statement will be displayed on the screen. 1, create operation. 2 means exit. Do while is there, no? So first I'll write output screen here. So at first it display like this: 1, create, 2, exit. Okay. After that, enter your choice. Enter your choice. If I press 1, so that 1 will be stored in C. This case will be executed. 1 is matches with this case. D dot create. So what has to be happened here? That function has to call this function. So what is there? Int star p. So these things are happening during the execution of program. So when I call that function d dot create, so this function is invoking and this line will be executed at the time of execution. So this is a dynamic allocation. So there is a memory allocation takes place during the execution. After that, what happens? A value will be entered in that memory location. That memory is identified by this pointer. After that, given integer is star p will be displayed. What is there in the star p? The content of that memory location. And that memory doesn't have any identifier. I hope you understood this program. Thank you.